You could use transformers for a lot of stuff. I would suggest not to use it for time series or reinforcement learning. Because time series, you want memory to you want to keep memory of the previous steps when you go to the next step in the time series, and residual networks are much better at that. But let's jump into how we could use these two things in tandem: Hugging Face and transformers. So here's just this random use case I made up. I want to make a robot that plays fetch with a dog. And this isn't necessarily just a robot that it's like a catapult you set manually. I want us to kind of understand the space around it and know how far to throw the ball depending on what room it's in. So if it's outside, I just want it to like throw it as far as it can. If it's in this room, I don't want it to like throw it through the back of a wall. So it needs to kind of have a spatial awareness. And to do that, we need images coming in from a camera feed in order to understand what's around it. And as an output, the model should figure out what its distance is to the objects and obstacles around it. So let's look at how we would do this in Hugging Face. So to apply the first step, we've defined the inputs and outputs. Now we need to research previous works. And you can do this on Archive and many other places. But let's use the tools that we're using today. So we'll go on to Hugging Face and jump into the Models tab. And over here, we have a series of filters that we could use. So our use case seems to take in images. So out of all of these categories here, computer vision would fit that best. And under here, we have different tasks in computer vision, such as object detection, image to image, zero-shot image classification. And we're not really classifying anything or defining objects. What we really want is depth. So I'm going to click on depth estimation. And so now we have all of these models that we can look into. And you can see that like there's a number of likes and there's a number of downloads. And you can kind of think of this as like, restaurants when looking at Yelp, where you want to find ones that have like a lot of likes and a lot of people downloading it. But to do research here, you can just click through each one of these and they'll offer deeper descriptions of what the model actually does. So this has a general description of how it works. It has a link to the repository and the code and the paper if you want to dive in a little bit deeper and read the whole thing. But usually these things are good overviews and give you an understanding of how many people are using them and if they fit with our use case. So it looks like we got an image coming in and a depth map coming out. That's really what we want. And this one is especially cool because it actually has all of the code here that we need for like a minimum viable product to see if this works in our use case. So let's throw this into a Jupyter notebook. So I'm literally just going to copy and paste this. If you're following along, you might want to pip install a few things. So you're going to want to pip install transformers. So we could use this transformers package. And then you want to pip install torch as well, because it's based off of PyTorch, as well as NumPy and Pillow, and possibly requests, but we're not going to use requests too much, so that is completely optional. So you're going to want these 4 packages: transformers, torch, NumPy, pillows, and requests. And to speed us up a little bit, I've already downloaded these. So let's just run this block of code and see if it works out of the box. So it looks like it takes in this image here, and then it outputs a depth down here. So let's take a look at each of these individually. So we have this image, we have a depth. So the image is a picture of, oh, that's really cute. A picture of 2 cats on a couch. And let's see how it did with the depth. So yeah, you can kind of see how the lighter pixels represent objects that are further away, and the darker pixels represent objects that are a little closer up. But we want to do this with our own data set, right? Like this is nice for now, but we actually want to apply and fine tune this to our own data set. And to do that, we need one more package. If you like pip install data sets, this is a really nice package that works with Hugging Face, where you can pull down any of the data sets in the dataset tab very easily and fine tune your model with it. So let's go through the same process of looking up what data sets are available for us in this space. So instead of clicking on models, we can click on data sets to start. And then the same categories apply. So let's look at depth estimation. And let's just take the first one. It looks like a few people like it, and it's been downloaded a bunch of times. So this is a data set of video sequences with indoor scenes using Microsoft Connect to actually make the depth map. And this is pretty good because you might actually want to use the ball throwing machine inside an apartment somewhere. All right, so just like the other part, it actually has some of the code. So I'm going to grab this and throw it in here. I'm going to make one change here. So this load dataset function has a streaming option. And if you've ever loaded a dataset, you'll know that it often takes a while if you're pulling down all the data because it's gigabytes upon gigabytes of data. This streaming option will only stream down the data as it's needed. So in this case, for our demo, we're only going to look at like 20 elements in the data set. There's no need to pull down like 500 gigabytes of images. So we're just going to run this block of code. And that's going to pull in our NYU depth data set. So we only want the first 20 elements. And to do this, we can say our data is the example, for example, where we just take the first 20 elements of the data set. And I forgot one argument here. We need to define the split. So usually if you're training models, you have a train, a test, and a validation split. And so we're going to define that we're training on this model. Just loading the training set of this NYU data set. Now let's take the first 20 examples. And even with streaming, it's going to take a few seconds. Are there any questions while we wait? Is it? Sure, yeah, I could increase the font size a little bit. That good? Oh, yeah, yeah. That's much better. Might be problematic that I'm using my phone as the Wi-Fi hotspot. All right, we might come back to this in a minute, but the basic idea that I want to communicate is that you can supply any data set here that you find in Hugging Face, load the data set, and then you could access it through any iteration that you usually would. The way you would actually access this data, let's say we took the first element of the data. If you look at the data set card, it actually gives you the shape that we're expecting. So we're expecting an image and a depth map here in a dictionary. So you could just index in with image or depth map. And for example, this is like an image of some apartment that doesn't look super great, but maybe you'd want to have your dog in here. We could also show the depth map by taking the data within the depth map. And passing it to Matplotlib. So we would import matplotlib.pyplot as plt, and then plt.mshow will show image data from an array of pixels. So now we have this ground truth of the image. And if we wanted to see how that compared to our model, we could actually just take this information here and create a predict function, pass in our image, indent all of this over here, and then just return this formatted element here. So now we could run this on any inputs we want. Pull that in. And then let's go down to here and just run our predict function and see how it compares to this baseline ground truth. So we're going to predict on the data, the first element of data, and we're just going to pass in the image. And that's going to return this array of information. So we're going to want to show it as an image using plt.mshow. Okay, so you could see that there is a little bit of difference between these two. It looks like it's predicting a much flatter scene here. The ground truth shows that there's a lot of distance between this back wall and this like front dresser here. Here, everything looks flat. It's getting the general shape, but it's not necessarily producing the depth and the quality that we want with this element. So this probably wasn't trained to work in this scenario. And so what we could do is take the data in this data set, run it through the model, train it as a PyTorch model, and we would get a depth estimator that would work much better on something like an interior of an apartment. To do that, I'm not going to go into much detail on the training other than how to use it, because it takes a while to train anything effectively. But everything that you use with transformers can be used with this trainer element. And this trainer class takes in a model, it takes in your data set, your evaluation data set, and then anything to compute metrics like accuracy or mean squared error. And then you just run trainer.train on it, and it'll train that model and output the weights. And then you can load those weights into the same model you downloaded off of Hugging Face and use that in your use case. So we've gone through steps 1 through 5. We've started with inputs and outputs. We've actually found a model, used that base model. We could fine tune the base model. This way we can validate it by loading the images and visually comparing them, or using something like accuracy or mean squared error. So this is most of the way through that part of the workflow. Are there any questions so far? Because afterward we could like work together and apply the workflow in the workshop. All right, well, if anything comes up, just let me know. Oh, okay, awesome. Okay, so we're 2 tools through, halfway there. Let's jump back into the presentation. All right, our third tool is Diffusers. This is another library where you can leverage community-created weights and create diffusion models. Now, what exactly is diffusion models? How do they work? Well, in the sense of, from the perspective of inputs and outputs, a diffusion model can do a lot of things, but it usually takes in some text or some sort of features and then generates an image or an audio file or something that's created from that limited set of information. While a lot of models take information of equal value, input and output, or refines a very complex piece of information down to a simple classification, diffusion models are generative. They take a small set of information and then they add on to it to create something that is more feature rich. And the classic example of this is Stability AI's Stable Diffusion, where it takes in just a simple text description with not that many specifics and then generates these amazing images. These generative models are great for when you're creating art or music or something like that from a very limited set of input features, so people can be creative with very little. it's not very useful when you are performance constrained in some way. So if you are using this model on a Raspberry Pi, you're probably going to be waiting a very long time for it to actually produce the output. And actually, we're going to jump through a quick demo with this. So how can we use diffusers? To start, you want to pip install it. So just like everything else, it's pip install diffusers. And then when we import it, you can just, we're actually importing a diffusion model class from diffusers. So from diffusers, import diffusion. I believe it's, let me take a look at the class name actually. Diffusion pipeline, okay. Diffusion pipeline. And just like everything else, you can go on Hugging Face and find specific models for this, but I'm just going to use Stable Diffusion's stability model because it's a really good industry standard. So I'm just going to call our model, import diffusion pipeline from pre-train. And the specific string that references this repository is runway ML / stable diffusion v1 5. And the one change I'm going to make to this, if you have a GPU, you're definitely going to want to convert them all to the GPU because these are very resource intensive. So I have M1 Mac, so I'm just going to make it metal. I'm basically going to make it accessible to my metal shaders and my GPU by doing 2 MPS. If you have like a NVIDIA GPU, you're going to do 2 CUDA. All right, so let's load this up. So the diffusion pipeline is a very high level abstraction. You can just load the models in and immediately use this, but they're made up of a series of different abstractions. There's a scheduler, which actually determines how the denoising works within the diffusion model. And then there's the denoiser model itself, which is usually something like a UNet that takes in a noisy image and slowly denoises it over a series of iterations. You can swap these out independently and get different results and fine tune each one. So if you want to dive into that, you can definitely look into the documentation. But let's see how this works. So if we just take our model and we call it with a description, like a beautiful landscape, it outputs a series of images, and we could take the first image and output it. And so this is going through, by default, a series of 50 denoising steps. And this is going to take about a minute because, like I said, diffusion models aren't necessarily the most performance and efficiency focused. They're meant to be run on a server with a lot of resources. And if you wanted something with higher fidelity, you would put in more iterations into this model's setup. If you want something that's faster but lower fidelity, you could just reduce the number of iterations to something like 10, and it'll produce something pretty decent. All right, and we get a landscape. So just with a couple lines of code, you're often running with your own diffusion model. And these models can be fine-tuned and improved upon. You could, for example, if you want the diffusion model to understand who your friends are, you can get like 20 pictures of each one of your friends and train descriptions of your friends with the images of your friends. And the model will be fine-tuned to understand when you say, like, for example, me and Arthur on top of Bishop's Peak. If I have pictures of me, pictures of Arthur, and pictures of Bishop's Peak, it would actually be able to refine those together into a really cool image. So that's a fun project if you want to check that out. All right, so that covers diffusers. We're going to move on to our final tool, which is Gradio. And Gradio is a user interface library for deploying deep learning models. Thus far, we've gone through steps 1 through 5. This is mainly focused on step 6. How do you quickly get your model out there so people can start using it and actually have your friends be like, oh, wow, that's really interesting and cool. So let's talk about the philosophy of this framework first. This UI library works off of inputs and outputs, very much like how we approach step one. And that's why it's a really good fit for this workflow. So you define what the shape of your inputs are. And in my example to the left there, the inputs, if we're making fries, the inputs would be potatoes. And we need to know like what that actually is. And then you define your outputs, like the shape of your outputs. Well, you're serving up fries in this restaurant. So you say, okay, my output's fries. And then you define a function. And the function is what actually takes you from those inputs to the outputs. And you can define it as a standard Python function that takes in arguments with the same shape as the input arguments, and then just returns something in the shape of the output. So you could do really whatever you want in there, as long as it's within the Python language. And with those inputs and outputs, it could generate a user interface for you. It could actually deploy a really powerful API if you host it on a server, and you could host all of these things on Hugging Face if you want for free, which is just a really cool feature. Okay, so final demo. Let's take what we have here with this stable diffusion model and make a user interface for it right here in the notebook. So if you want to use this library locally, you first need to pip install Gradio. But I have it installed already, so I'm just going to import it. So to import it, you import Gradio as gr. And Gradio has this class called an interface, and that's the base level of any application user interface that you're creating. So to bring it up, you do gr.interface. And just like the model we described before, it has inputs, it has outputs, and it has a function that they denote as fn. So I'm going to make a function here. I'm just going to make it do cool stuff. And then we're not going to do anything with it right now. We're just going to pass it into this interface so that Gradio has access to it. And then we'll build up from here. So we pass do cool stuff to this Gradio application. Now we have this model that we already have pretty much everything for. Our function is almost written for us. We're just going to copy what we did before straight into that function. But first we need to define our inputs and outputs. So what's our inputs? Text? Exactly, a string. So Gradio is really easy. It has these like stringified class references. So if you want something just like text, you could just literally say my inputs are text. And then now you've got your inputs. How about outputs? What are outputs? Yeah, like an image of some sort. So Gradio has an image output by default. And now we've got this do cool stuff function that needs to conform to this. So we have an input of text, and that's of type string. And then we have an output of probably like an array of pixels. So I'm just going to put a NumPy array here because that's what our model returns. And then we take what we have up here, paste it directly into the function, and just return that. Of course, we need to change the inputs of the model to text. And it seems like it is returning just an array of images. And we're just taking the first element. So to launch the application, all we need to do is type in app.launch this. And we have an application right here in our notebook. You can actually deploy this to the internet and it'll look exactly the same. So someone give me a short prompt. We should try this thing out.
A horrifying landscape.
Is it horror?
HORRIFY.
Landscape. Okay. I am not responsible for what comes up here, but yeah, we'll see what it does. So you'll see that it's walking through the 50 steps that we saw before. And in a few seconds, it's gonna pop up with a horrifying landscape image. It'll be fantastic. I'm sure. A lot of these models have, ooh, I like that.
Probably.
Yeah, great. Very seasonal. So the thing about that was, I think the output image was fantastic. But maybe for a talk, that's a little bit long to wait, right? I was just kind of standing up here and you guys had to just like watch me boop around while the image showed up. So I want to add in a little bit more control here. I actually want to be able to refine how many steps that this takes. And if we want to change our user interface to dynamically add this in, we could do this very simply. So inputs could actually accept an array of elements. And those elements could either be the textual description of the class, or they could be the class reference themselves. So the Gradio actually has a slider class that we can use to determine the number of steps that this model should take and input that before we run the text through the model. And this accepts some parameters. So if you just open the parentheses, you can see that we have like a minimum, a maximum, and then like a default value. So I'm going to say at minimum, it's probably good to make the minimum 0 just so the user doesn't put in a negative number and blow up our model. Let's set a maximum to something like 100 so we aren't waiting years. And then a default value of what we had before, like 50. Now, because we changed the input shape, all of these are going to be spread into our function in the same order that they were defined here. So in addition to our text, we should put a number of steps value, which is going to be an integer. Now, this model actually has a number of inference steps parameter that we could put in, and we just pass in num steps into that. And now we have a brand new function where we have more control over how this works. So we have a slider right here. You could put in the value, you could increment, decrement. And this is really useful for both deploying the application and for just playing around. If you want to see how an application works, if you want to parameterize it, it's as easy as just changing the inputs and outputs right here in the interface. Does anyone want to give me another prompt? So we could try it with only 5 steps.
A robot and a dog playing fetch.
A robot, yeah, and a dog playing fetch. Very on theme. I like it. Okay, so this is only 5 steps, and you can see it happens in 5 steps. And like I said, if you reduce the number of steps, the number of iterations, it's going to be blurrier. It's not going to be quite as refined. But actually, though it's not exactly what we wanted, I like how this looks. It's very interesting. It's kind of abstract in many ways. All right, so Gradio is amazing for deployment and just for playing around with your models. Are there any questions before I move on?
Would there be a way to display different images at different steps for the same command?
Different images at different
Like
steps?
at 10, this is what it looks like at 10, this is what it looks like at 30, at 50.
Yes, yeah. So I believe I think you can go in here and change, you could adjust the outputs here. So you could adjust the output to take an array of images. And then inside your function, I don't quite know how to sample at different points in here, but really what this model is doing on the inside is it's taking a noisy image, it's running it through the model, and then like reassigning that image to like the noisy image, and then just looping it through the model for the number of steps it's going. So it's very, if you had your own specific denoiser, you can just kind of like snapshot images as they go along, and then you could return an array of images instead of just a single image, and they would all show up like one after another in the output. So that's one of the ways you could do it. And that's a really great way to debug. It's a good question. Yeah, anything else before I move on? Yes.
So for if you uploaded something like this on Hugging Face, who would actually be providing the compute power?
Hugging Face.
They do.
They do, which is pretty incredible. They do for CPUs. So if you have a really big model that requires like a lot of compute, the CPU is not going to cut it. And you're probably going to time out on those circuits. Something like this, you could probably still run on the CPU. Both of the models I have up there are fine with the CPU, and I just keep them up there for free. So for most use cases, I'd say it's sufficient. Yeah. Did you have a question?
No, I didn't actually.
Oh, sorry. Anything else? Yeah.
Is that what you were, did you use Hugging Face for your dance sampling?
Yes, that is what I use Hugging Face for. Yeah, I used the Transformers library for that. So I collected this is a project I worked on a little while back where I wanted to take in song audio and then output a classification of what ballroom dance styles you could dance to those songs. And I curated my own data set, but I needed to test it on a bunch of models. And the brilliant part of using Hugging Face and using Transformers is I don't need to go create all these models from scratch. I just pulled down like 5 different models that people use that were similar, like audio classification models, and fine-tune them on my data set and then pick the best one. So yeah, it's a workflow that I use pretty often. All right, so I'll jump back into the slides. All right, we've jumped through the 4 tools, but I did want to mention some other amazing tools that are kind of like honorable mentions of this talk if we had more time. Those tools are Spacey and NLTK for NLP use cases. So if you're doing any sort of natural language processing, like translating languages, summarizing stuff, Spacey has really good out-of-the-box models for parts of speech classification, for just breaking down sentences to like be kind of like a front end for your chatbot so that you can refine the output that you might want later down the road. NLTK was the default for a really long time. That's going to be more classical machine learning, n-grams, stemmers, just using like Bayesian approaches. It's not going to be like the deep learning stuff that we covered today. But they're both really useful tools. Recommend looking into them. If you want to go into like large language models and that sort of thing, LangChain is great. It allows you to put a bunch of large language models together. So you might have like ChatGPT, Llama, and Bloom all running in parallel using APIs. So if you have an application, someone submits it, you could actually send their input to all these models, cross-reference what the models return, and return the common source of truth. And this is a really great way to make sure that your model isn't just hallucinating and like one model is giving them bad output. Yes.
So I was actually around when LinkedIn was that first came to May, January of year.
Yeah.
December. And from what I remember, it was about like making the models free and everything. So you just pull the best free one and like whatever at that specific moment in your application, whichever one is the free one, you take and you get everything for free.
Yeah. So you can define how it pulls the models. So yeah, if you want to optimize costs, you could say like, give me the freest model, give me the fastest model, give me the model that's best for this use case. So it's like the logic around how you use the entire ecosystem of models, and it keeps it kind of high level. That's a really good point, though. Thanks for mentioning it. Yeah.
What are these others? Hugging Face, Candle, PyTorch, Lightning. I mean, I know PyTorch and TensorFlow a little bit in general, but
Yeah, I can go into detail here. So TensorFlow Hub is kind of like Hugging Face before Hugging Face.
okay.
If you really like TensorFlow, I definitely recommend looking at it. You can load TensorFlow models from it. But Hugging Face also has like TensorFlow models that you can just pull down. So it's a little bit more broad and it is more used by the community. To answer your question about PyTorch Lightning is a framework that is wrapped around PyTorch. And it provides a standardized way to define your models, the training environment, the data loaders, and the data sets. And it allows you to mix and match them. So for my dance project, I created different modules for each one of those models that I was throwing in. I had slightly different data sets. I had one that I scraped from YouTube. or allegedly scraped from YouTube. There was another one that I pulled from an online database. And I needed those to have the same shape of data coming out of them. So I could define those data modules in PyTorch Lightning and then mix and match models with data sets, and everything just works seamlessly. So it's a really, excuse me, it's a really good tool for doing research and training your own models. And then Hugging Face Candle is probably, it's one that I threw on there because it's really cool. It's not really super mainstream, but it's a new library that Hugging Face released like a month and a half ago, and it's a machine learning framework written entirely in Rust. So I used Rust a lot for my thesis. I did a lot of open source work in Rust. It's a great language, and it's just so fast. And the cool thing about it is you can develop your models in Python, which are going to be slower to run. But when you actually deploy these models, you want to run as fast as possible. You don't need all the ergonomics around it. So the Candle library works with anything you build in Python and PyTorch. So you can just develop your models in Python, load them in Candle, and now you have stuff running at like C++ speeds in your deployed server. So worth checking out. Yes.
A couple more questions. Okay, so one of them was, it sounds to me like PyTorch Lightning can save us a lot of time on data cleaning, because it'll make your data fit the way you want it to.
Yeah, so you still write your own cleaning logic. Like
Okay.
you could think of it as like all these data sets have different output shapes, and then you write your cleaning logic in the modules to hit the same output shape. And then you could mix and match the modules so that like you have like your data input flow, a module that cleans the data to hit this common output, and then it flows into this model with that common input and output. So you can kind of like mix and match them like Legos, and then you handle any content specific information inside those modules.
Oh, that's great.
Yeah.
Great. Do you have any opinion on Mojo?
Mojo, like the new Python thing?
Yeah, superset.
Yeah, I haven't looked into it that much. I just know that it's really fast and it seems very cool. I like that they're building off of Python and making it a superset so that you could actually like kind of add types into Python, and like they have a really cool JIT compiler that I recommend looking into. And if you want something that has like similar JIT compilation that's in Python, check out Jax.
Yes. Okay.
Jax is really amazing. Yeah.
So I'm just curious about this Hugging Face Candle. Is this specifically just in like Rust, or can you also write it in Python, or what's the deal with it? Like,
It's in Rust. So Python has a dynamic runtime with garbage collection. Rust does not. And so if you load your weights into Rust and you run the model in Rust, you're going to have a more fixed memory size. You're going to be able to manage memory a lot better. It's going to be more fast and efficient. And so that's the advantage of Hugging Face Candle. I wouldn't develop in it. I mainly deploy in it.
so like you load the model that you already like developed into Rust, and then you deploy it from there.
Yeah, so like let's say you have like a PyTorch model. You could do like pytorch.save myweights.pth. And then you have this weights file, which is basically the actual values inside that defines the architecture of the model. And then inside Candle, you do candle.load, you point it to that file, and it loads the same model that you created in Python into the Rust runtime, which is going to be a lot less overhead. It's going to be a lot faster, but the model behaves exactly the same. So no loss in fidelity, just increase in speed.
So you would essentially be running this Rust code like in an actual application. You'd be running it on the cloud, running it on the cloud.
Yes, yeah. So you would be like, you would train everything in Python because it's more ergonomic. You have all the tools you enjoy. And then when you deploy and you want to keep your compute costs down and make this thing super fast, then you would deploy it with Tremble. And it's still very early days, so I wouldn't recommend if like you're, for example, at an internship and you're deploying something really big, don't use Candle. Use it for your personal projects until it becomes standardized. All right, so wrapping up, we covered 4 tools today that are very interrelated. Hugging Face, which is where you would look for models and data sets that you would apply to a specific problem. Transformers, which is a library that enables you to train transformers locally, fine tune them, and run inference with them. Diffusers, which is more for generative applications, but has a very similar interface that works very well with Hugging Face. And then we have Gradio, which is that step 6 for deployment, creating the user interface so people can use your models and extend them. And a few takeaways, there's a lot of community resources. I would highly recommend standing on the shoulders of giants rather than starting from square one, because there's just so much out there that probably gets you 90% of the way to solving your problem. And that builds into step 2, just refining prior works to solve hard problems instead of starting from square one. And then I always recommend deploying, because even if you create something that's really cool, you want that positive feedback loop. You want your friends to see it, and it really helps motivate your next project. And if it's not on the internet, it doesn't really exist. You're not having as big of an impact as you possibly could have. So always deploy at the end. Yeah. All right. So now we're jumping into a workshop. And actually, I'll pause for questions if anyone has any questions. Yes.
Can you briefly explain transformers again? I didn't really understand what they're doing.
Sure. So like what they do in terms of inputs and outputs.
On like a wider scale.
Yeah, so transformers can be used for a ton of things, but essentially what they're doing is they take in like a series of inputs and they weigh the relationships between adjacent inputs, figuring out like what's the pattern in this data. And then they can use a mapper that translates that pattern to an output. So you can use transformers for a bunch of things, because like that description is really vague and kind of strange, but it's intentionally vague and like kind of high up, because you can now apply that model to a bunch of things. You can use it for image classification. You can translate between languages, because those are just sequences of words. You can use it to translate between two audio things. You can use it to denoise audio, because that's just a sequence of bytes that is the amplitude of the audio. So transformers can be applied in so many different areas. And they're kind of the de facto tool that people use nowadays. Sweet. So I'll just cover the workshop. It's basically what I did a couple of times in the talk, where we're going to define a problem, your own problem, whatever you want to solve. Then go to Hugging Face and find a model that looks cool, do your research, pull it down locally using something like diffusers or transformers, and see if you get the model running locally with just like a single input and producing a single output. And then use Gradio to build an application around it. And once you do, I'll show you one additional fun feature of Gradio. If you, in this launch function, type in share equals true, you can actually get 72 hours of free hosting from your laptop to anywhere in the world. It just creates a site for you on the internet, on like this Gradio live site. So I could paste this into our Discord, for example. And now y'all could load it on your phones or your laptops and run it on your computer. Word of warning, if all of you go on at the same time, it is running locally on my machine. So this thing could catch fire. But yeah, try it out. It should look exactly the same as what we were showing on the screen. So if you get through all the steps in the workshop, please like share out your final product. Like just put it in the Discord, have share equals true, and leave your laptop running for like, I don't know, like 30 minutes, and let people test out what you did. And I'll be walking around ahead. Are there any final questions before I set off? All right. Good luck, everyone.
Oh, no.
It looks like it's.
Yeah.
Okay.
Index error, it's the same.
You got something? Yeah, it looks like I'm ready to start. I can start that after.
No, I want you guys to fill out our feedback form. Let me just put it up for you guys 1 second.
Actually got it to work, just like, I just reduced the number of steps.
Oh, okay.
Yeah, it's probably just maxing out my GPU right now.
Disable the screen share.
Please, feedback form.
Thank you, guys.
Send me riddles.
Let's toss some much data.
I'll post them open some.
Oh, nice.
Alright.
It's,
Yeah, well. Oh, yeah. Then I give yeah, thank you.
I guess they don't like to trail out.
Yeah. Yeah. So.
So yeah, it's not like, it's not one of just.
Alright, guys. Thank you for coming today or watching online. I'll try and dub over the audio or something so that you guys can watch the first 15 minutes.
Oh, yeah.
Yeah, thank you for coming today. I'm gonna end the recording.